friends, welcome again to another episode of Beyond the Clouds. If you look at the complexity of emerging technologies, I've been in it for a very long time, and still I barely understand maybe 10%. And that's the reason I talk to people from different parts of the world who are doing different things. Garibay has been in this space for quite some time. Ty, tell us about your story. How did you become the Garibay we all know today?
Thank you for the invitation to chat with you in this space. Certainly, you've had some interesting guests. I was blessed coming out of university to end up starting my career with the 68,000 team at Motorola in Austin. And really that started me on a path of working in microprocessors and high performance systems that I've stayed on for more than 35 years now. I've had an opportunity to participate in 68,000, 88,000, PowerPC, ARM, x86, MIPS, some others that don't really have public names, and now RISC-V with my new startup, Condor Computing. So it's been a lot of fun. And then along the way, I did some FPGAs, SoCs, AI accelerator. I've gotten a chance to be involved in a lot of different technologies and learn and pull together a lot of different technical aspects from all these things over time.
That's really amazing. I was on the other side at Intel on the 486 and Pentium when you were at Motorola on the 68,000.
Yep.
And I remember distinctly, Motorola would every year win the quality award, the Malcolm Bardridge Award.
Yeah,
And
that was a corporate
Andy
thing,
Grove
yes.
put it as a challenge to all of us, saying, look, we make the processor and these guys are winning the awards. What's going on?
I'm glad actually somebody noticed. We always wondered if anybody noticed that.
How did this focus on quality mold your career? You worked with companies that have made some of the most amazing technologies.
It tended to shape the more senior engineers that Motorola had and retained and chose to lead. And I learned from those guys. The guys who created 68,000, 68020, 68040 were my mentors, and guys who went on to create PowerPC. Those senior engineers had absorbed the years of quality focus and process focus that led to those kinds of quality successes. That definitely has shaped how I approach each new challenge, with a focus on how do we establish processes that allow us to take on huge multi-year challenges. Startups are fun. You get to make it up as you go along. But even then, you have to bring it all together in the end.
Interestingly, you worked on the very first version of RISC at MIPS. You worked on x86, you worked on ARM, and more recently with Mythic on one of the early AI chips as well, and now RISC-V.
Yep.
So which of these things that you worked on would you say you learned the most, whether it's technically or business?
Yep. So technically, early on in my career, I had an opportunity to join Cyrix, x86 clone CPU maker. We didn't know what we didn't know. We set out to make the first totally clean room x86 compatible CPU. And we did. We did it with about 25 people in a year and a half. At that time, it was a great accomplishment. And then, I had an opportunity to get more involved in the architecture definition of following products. For one fleeting instant, we had the highest performance CPU in the world until Intel got a little upset and decided to show us how it should be. In that time, I learned everything from being a full custom circuit designer all the way through RTL, verification, microarchitecture, architecture, performance modeling. It was a fantastic opportunity to work with some amazing engineers. In the end, a lot of us went on to be technical leaders in companies throughout the industry. It just turned out to be a great team. We created some products that were cool for the time. It just, in the end, wasn't sustainable as a separate company and kind of went down the drain as it got bought by a National that had different business interests.
I still remember the acquisition of Cyrix by National. I was on the other side at Intel watching a tiny startup beat us, and we were the kings of the x86 market. And yes, again, is the David versus Goliath story. Speaking of which, you got into RISC-V after all the early chips were all the tiny ones making embedded processors, IoTs, but you're doing something much different. Where do you see Condor Computing getting into RISC-V, and what are the
Yeah.
possibilities ahead of you?
So we're not talking a lot about Condor yet, but the goal is clear. Our goal is to have the highest performance licensable RISC-V CPU in the industry. Everything we're doing is targeted at building a team that can create that licensable IP in very short order, make it available to customers, and support customers to a successful deployment in their own SoCs.
Is there a reason why you would sell the IP or the IP platform rather than go all the way to silicon?
It's a business choice. The level of investment necessary to get to IP sales, of course, is much less. It allows us to really focus on the processor and the microarchitecture and the architecture of the CPU itself, as opposed to looking to the end application. It also lets us not build up a full silicon tape-out team. So from a cost point of view, it's dramatically lower. Who knows? One day we might do silicon, but I think that we can be very profitable as a licensing agent, especially in this current environment where there aren't that many players at the high performance end in licensing in the RISC-V space.
And you have the experience having been at ARM as well as at MIPS to see how the licensing models work.
Yeah, certainly I'm aware. A number of the folks that we've hired are aware of how to design for licensing. It's a very different type of design. I've also been on the other end of it, trying to license IP that was designed internally for internal use. And that's very hard. That doesn't go well usually. We are planning everything with the target of meeting external customer needs in terms of configurability, verification, tools, testing. All of that is being developed from the beginning, targeting an instantiation into a customer system. And I think that'll make a big difference for potential customers when it comes time for them to evaluate high-performance RISC-V CPUs.
I was at Intel when I first learned a lot about RISC-V, and given the complexity of these designs, given that Moore's law is slowing down and we need to move towards chiplets, it makes a lot of sense. What do you think will happen to the other existing architectures, particularly ARM, that have been around for a very long time?
ARM will always be there. They have a ecosystem that is second only to the x86. They have enough of a traction in multiple industries that they can continue for a long, long time. There's room for another player. Well, what we're seeing already is RISC-V is taking over a lot of the sockets where the ecosystem doesn't matter, where the CPU is not exposed to the end customer, or at least not exposed in terms of deploying third-party software. So if you're developing an application where you as a chip developer are going to control all the software, own the entire stack, and deploy the chip into a system yourself, RISC-V is almost a no-brainer as long as the CPU is there that can meet the performance need. And that's why Condor exists. Right now, there is no CPU that can compete with the A78, Cortex X2, 3, Neoverse V2 range of ARM processors. And so there's really no choice. If we can create a choice, I do believe that there are applications that are not running a open OS or are not configured to allow a customer to deploy, change the software load, where RISC-V versus ARM versus x86 doesn't matter. And really the choice can be made on both a technical and financial basis by the customer.
That's true, especially as we get more and more into bespoke silicon for many vertically integrated markets. Speaking of which, at the Consumer Electronics Show that just concluded, there were tons of PC AI, and AI was everywhere. Where do you see RISC-V playing a role in this exploding AI market?
For everything but PC AI, RISC-V has been dominant. If you look at all of the AI accelerators, almost all of them were based on RISC-V as the primary programmable CPU. And then every company added its own neural network accelerator special sauce. By definition, RISC-V is dominating in the bespoke silicon market for AI. What's interesting, you mentioned the AI PC. That starts to move things back towards the traditional architectures, x86 and ARM. So Qualcomm developed an architecture, still has their proprietary ARM core as the primary CPU. with a lot of their own AI accelerator built onto it. Intel is doing the same thing. They're adding proprietary neural network accelerator to the full chip SoC of the x86. And so what we're seeing is kind of what we saw 15, 20 years ago with graphics. We had in the 90s an explosion of graphics companies. There were 20, 30 graphics chip companies back then, and it was going to be the next big thing. And then it wasn't, because there really wasn't a high volume market for adding $200 chips to a system to do graphics. Almost all of them failed, and we know what happened with the one that survived. Other than NVIDIA, there was a massive die-off around the dot-bomb time. What happened really is that the graphics became an IP. It was eventually merged into SoCs as SoCs were created. And so at TI, we brought graphics onto the OMAP SoC, and that really created the smartphone. Apple did the same thing with their initial smartphone SoCs. Everybody was using Imagination IP at that time. And then graphics came back, primarily as an included feature in computing SoCs. And I think personal computing or interactive computing applications, that is probably going to play out the same way again. The vast majority of AI will be done on computing SoC platforms with integrated either chiplet or directly integrated onto the SoC accelerators, some licensed, some proprietary, and that will drive the large acceptance of AI processing into high volume. You'll always still have, just like we do today, you have gaming GPUs, right? For people that just want that next order of magnitude. So there'll always be cards of more AI and servers of AI. So that market will exist, but I don't see too many players other than the traditional providers getting into that AI PC space, because you have to have the PC part first.
In fact, I was at one of those 3D graphics companies, S3. We made the first commercially viable x86-based 3D graphics chip. But soon it became an IP in the Intel ecosystem and the AMD ecosystem with the acquisition of ATI by AMD. Talking about vertical sectors, the automotive, we've seen this whole supply chain issues starting from the pandemic onwards, with electric vehicles, autonomous vehicles, hybrids becoming the vogue thing. Do you see RISC-V playing a big role, and the kind of IP that you have playing a big role in it?
Absolutely. That's a huge opportunity. It's also a big challenge, of course. If you're going to play under the hood, you have to do all of the necessary functional safety type things. And that takes a lot of time, takes a lot of effort, takes a lot of simulation. There's a trade-off in terms of time to market and accessibility of that market. What we're seeing today is that ARM has really made a huge inroads into that space, with NVIDIA and Qualcomm driving a lot of silicon there. Intel at CES made no bones about it. They said, we're going to try to take over the car. I do believe that it is a market that RISC-V can play in, take a lot of shares for most of the automotive applications, other than the user interface big screen, which generally has to run Android or some type of OS. Nobody cares what kind of processor is in those CPUs. It's been everything from PowerPC or Power even to MIPS. There's still old Motorola microcontroller things in there, 68HC15. It's a open playfield for the next generations based on RISC-V if the appropriately validated and verified ISO 262 compatible CPUs are available. It's a great market to get into. Because of electric vehicles now, it was super hard to get into automotive, and then it was super hard to get out. So it was a great business if you could get in. Things are moving now towards where cars look a lot more like phones, and there's going to be a lot more turnover in the silicon over the years as cars are created to be upgraded, at least model year to model year. That creates a lot more opportunity. Every major car vendor is creating their own proprietary chip design teams. Mercedes, BMW, Volkswagen, they're all building big silicon design teams to be able to own the full stack. That's another good reason to get into the licensing side. I can't compete with those guys for their own chips. I can deliver IP to them to meet their own goals with their own proprietary SoCs.
Condor is a very beautiful name. What's the history? Who came up with it?
I did. History is, it's the biggest bird and it flies the highest. The fun part, of course, is that it also uses the least energy while it flies.
I remember reading the history of Condor. They can even fly when they're sleeping. Is that right?
Mm-hmm. As I said, low energy, flying high with low energy. That sounds like what we want to do, right?
I was a hardcore R&D engineer when I started, and for a long time I enjoyed it. But these tape outs and getting things done on schedule and quality, power, performance, everything that you're talking about, I got burned out. That's why I went on to the dark side in marketing and then customer support and so on. How do you make that work-life balance happen?
You might have to ask my family whether I did or not. I find that the work itself is fun for me. Or if it's not, I don't do it anymore. I find something else to do. That's kind of how I've ended up doing a lot of different things. The balance is there for me in that I enjoy what I'm doing, whether I am working or I'm, with friends, with family, whatever, by myself. That I'm able to sustain for long periods of time. You have periods of time when you buckle down and you got to focus. Sometimes those go on longer than you like, but generally there's a time that comes after and it's less hectic. Even in a startup environment, there are times where you have to dial it back and say, okay, that was a win. Let's celebrate and cool off for a few weeks. Keep getting good stuff done, but maybe bring the pace down a little bit. Again, having done this for a long time, I feel like I can judge better now than I used to when you have to make those choices to pull up a little bit and recover, get some more energy back, and then dive back in and make it happen again. That's where experience helps a little bit.
When you and I started in the industry, it was enough to know switching theory and logic design, maybe a little bit of the chip design process. Today, everything is expected to be done by a small team of engineers, and the complexities have just gone up like crazy. What advice do you have for people joining the industry?
I had been with a startup called Mythic up until about a year and a half ago. That was amazingly complex. We started from basically device physics and worked up through the stack through transistors, analog design, digital design, microarchitecture, architecture, software, embedded software, AI training, AI inference. We had to cover that entire range of technical topics with a startup-sized team. That was a huge challenge and a lot of fun until it ended. So those are, to me, an opportunity. Where else in the world can you be involved in that range of things? Now, if you really want to focus, you can focus. You can be the world's best digital designer. You can be the world's best analog designer or embedded software engineer. But a lot of startups really give you an opportunity to be involved wherever your interest goes and where you have the energy to contribute. The one thing I think that is common now across almost all the disciplines, including software, is the people who are the most successful are the ones who think about, how do I automate this? How do I do it once, automate it for the second time? Most people think that, oh, I did that, it's done. No, you're going to do it again, dude. Some level of programming skills, Python especially, is critical for all engineers now. Bringing an awareness of the task, a process focus to work, so that you can identify what is an input, what is a process, what is an output, and try to figure out, okay, how would I make that an automatable process in the future, is really what differentiates extremely productive and successful engineers today from just good, smart people. The more that you have that can think about automation, implement that automation, test it, and validate it for reuse, that's a differentiating factor for a disproportionately successful team.
I agree with you. The complexity of these systems is so much that people who are making these chips and systems for AI and high-end applications have become the new rocket scientists. And they may even help design rockets in future with a high level of automation, right?
Yep, absolutely.
It's exciting talking to you, Ty. Every time I talk to somebody, I learn a lot because the complexities have gone up. Even engineers like you and me who have been in the field for a long time need to refresh ourselves, and this is my way of refreshing.
That's awesome.
And to people listening out there, don't feel threatened. There's so much to learn. Yet, there's also automation. A compromise between letting some things get automated and some more things to learn is evolving. And please keep up the good work. If you have new things that you can talk about, please come to me. I would love to listen to you. Ty, it's exciting to find out the multitude of things you worked on, and looks like you will continue doing that in the next few years because you seem to enjoy it so much, that childlike
Absolutely.
excitement of doing things. So please continue full steam.
Appreciate it, Shankar. Thank you for having me again.